Not all electrons are equally weighted, as the electrons in the outermost shell, or valence electrons, are critical in the properties of a given atom. This is due to the fact that all electrons are equally charged, but using Coulombs Law, it can be seen that the outermost electrons face the least attractive force. This is because they are the furthest away and don't feel the positive charge of the nucleus as much as the core electrons do. So these are the electrons that are exchanged between different atoms and accordingly give the atom its properties. Valence electrons don't feel all of the positive charge of the nucleus as the core electrons shield them. Instead, the valence electrons feel the effective nuclear charge, which is the net positive charge that is reached by subtracting the total amount of core electrons from the amount of protons. Valence electrons are very important in the creation of bonds, as the atoms within the bonds will always tend to seek a full outer shell of valence electrons, as this is where they are most stable. This can be achieved by an atom in either gaining electrons or losing them. Nonmetals generally tend to gain valence electrons to fill their octet, so they will tend to have a negative charge and ion form. The opposite is true for metals, as they give up electrons to form ions, gaining a positive charge. In the periodic table, there are trends in electronegativity, atomic radius, and ionization energy. These are all due to the relationship between the valence electrons and the nucleus. Atomic radius increases as you go down the periodic table and to the left. The radius increases as you go down the periodic table because the valence electrons are further out due to the change in valence shell. And the other valence shells repel each other, so they cannot be in an incredibly close proximity. Relatively, of course. The atomic radius increases as you go to the left on the periodic table because the effective nuclear charge decreases and the valence electrons feel a lesser force due to Coulombs Law. Electronegativity is most simply the tendency of an atom to attract electrons. It is measured on a 4.0 scale where 4.0 is the most electronegative, meaning it attracts electrons to fill the valence shell the most. As you move to the right in the periodic table, the electronegativity increases as these atoms are closer to achieving a full valence shell by receiving electrons rather than giving them away. The electronegativity goes down as you move down the periodic table as the atomic radius increases and the valence shell that the electrons would gain are further away from the positive attractive charge of the nucleus. Using Coulombs Law, you can see that they would experience a lower force than in an atom with a similar effective charge, but in a lower atomic radius. The last periodic trend I will go over in today's video is ionization energy. This is related very much to electronegativity, but is the opposite of it. This is due to the fact that in electronegativity, an atom is gaining an electron, while ionization energy is the measure of the energy needed to expel all of the electrons from the valence shell. Moving left to right across the periodic table increases ionization energy, as the atomic radius is smaller, so the electrons are more attracted to the nucleus, as well as facing higher effective nuclear charges. The ionization energy decreases as you go down the periodic table as the atomic radius increases, while the effective nuclear charge remains constant. So the valence electrons that need to be expelled are experiencing the same positive pull, but from a further distance. Therefore, they have a weaker attraction. I hope this video was able to help your understanding of valence electrons and ionization energies. As always, this was JNA Chemistry. Have a nice day.